Hi guys, and welcome to the spiral corrections for week 23. As always, make sure that you are writing full corrections for anything that you missed and not just the answer. Monday, an amusement park line for passengers waiting to ride a roller coaster is moving about 16 feet every 10 minutes. Jason and his friends are standing 40 feet from the front of the line. Select values to set up a proportion to represent this situation. So the first question that's going to come up, you're going to use these values here and write a proportion to represent this situation. Part 2, solve the proportion to determine how long it will take for Jason and his friends to reach the front of the line. All right, so I started with my initial ratio or my rate, 16 feet every 10 minutes, and that's my first ratio. And when I'm setting up my second ratio, remember we want to line up like terms. So feet needs to be across from feet, minutes across from minutes, and that would be my correct answer. Down below, here I solved the proportion using cross products. I multiplied to get an equation, and then I divided to isolate the variable, and it would take 25 minutes. Tuesday, the table shows the cost to have various numbers of pizzas delivered from Papa's Slice of Italy Pizzeria. Is the relationship between the cost and the number of pizzas proportional? Explain. So it's going to pause. Over here is the problem for the pizzeria. So we want to know if cost is proportional to the number of pizzas. Next one, Brenna charges $15, $30, $45, and $60 for babysitting 1, 2, 3, and 4 hours respectively. Is the relationship between the amount charged and the number of hours proportional? If so, find the unit rate. If not, explain why not. All right, so I have my work down here in the dark blue for my pizza problem. So I say it's not proportional because when I wrote the relationship of cost to number of pizzas and reduced them all to unit rate, I'm not getting a constant rate of change. I'm not getting a constant rate. It should all reduce to $12.50 for one, but as you notice, it is random for all of them. Then for the babysitting problem, I did the same thing. I wrote the rates 15 to 1 and then each additional rate and put them in unit rates. And this is proportional because they all reduce to a constant rate of $15 per hour. Wednesday, the ordered pairs 1, 4, 3, 12, and 5, 20 represent the distance y that Hiro walks after x seconds. Plot the ordered pairs on the coordinate plane and draw a line through the points. After you do this, you're going to find the slope of the line and explain what that slope means, what it represents. So right now it's going to pause. You're going to use the slope formula. Remember y2 minus y1 over x2 minus x1, and just pick two of the ordered pairs to use. So go ahead and enter what your slope is. The next thing, choose the answer that tells what the slope represents when it relates to distance and time or time and distance. I went ahead first and plotted the points and connected a line, so that's what your graph should look like. So if it doesn't, make sure to adjust it. Then when I'm finding the slope over here, I used y2 minus y1 over x2 minus x1. So the ordered pairs I chose is 1 and 4 and 3 and 12. I could have used 5 and 20 with another ordered pair. It doesn't matter which two that you use. So I labeled my first set as x1, y1, and my second set as x2, y2. And then I substituted my values. 12 minus 4 is 8. 3 minus 1 is 2. I reduce to lowest terms, and the slope is 4 over 1. So again, what that means, remember it's y over x. So y is the distance, 4. X is the 1, which is seconds. So this means that Hyro walks 4 feet per second. Thursday, determine if each relationship is proportional. Explain your reasoning. So there are 4 situations here. I'm just going to read through them and pause. It'll pause and you'll answer not proportional and why, or proportional and why. Choose the correct answer for each one, and then the answer key for all 4 will show. So first one, taxi cab passengers are charged $2.50 upon entering a cab. They are then charged $1 for every mile traveled. Is this proportional or not? Second one, a restaurant charges $5 for 1 sandwich, $9.90 for 2 sandwiches, and $14.25 for 3 sandwiches. Is this proportional? Is this not proportional? And why? Situation 3, this guy over here. Go ahead, and we want to know if the cost of tickets is proportional to the number of tickets purchased. Last one, we have cups of flour and cups of sugar. So we want to know if the cups of sugar is proportional to the cups of flour all the way throughout the table. All right, starting with the cab, this is not proportional. It's $2.50 upon entering, and then $1 for every mile. So the first $2.50 charged at the beginning will prevent a constant unit rate, because if we keep putting for 1 mile, for 2 miles, for 3 miles, it's not going to reduce to the same unit rate each time. For the restaurant charging for the sandwiches over here, I went ahead and reduced each rate to a unit rate, and it's not consistent. There's not a constant unit rate, so that means it's not proportional. The price lowers as the number of sandwiches increase. Going over to the tickets purchased and the cost, again from the table, I just wrote y over x, so cost on top, and you could see each of my unit rates. When I went ahead and reduced, they all reduced to $7.50 for 1 ticket, which means yes, it is proportional. And then for the last one, the cups of flour and cups of sugar, I wrote the cups of sugar y over x, and I reduced each one, and every single one reduces to 6/10 repeating over 1, which means yes, it is a proportional relationship. So make sure if you missed anything that you're pausing it right now and writing a full sentence. We should see full sentences, because when it tells you to explain, you're supposed to write sentences to explain. Okay, you're halfway through. Here's a weekly picture of PJ. He's practicing his sit or his lay and wait, where he has a treat on his paw right there, and he can't take it until I tell him free. Turn to the back. We taught you guys volume this week, so you will start seeing volume of prisms this week, moving on to cylinders and then back to the geometry review. Again, you're writing the formula, substituting your value, finding the answer for every single one of these. A full correction is necessary if you do not get it correct. Number 1, find the volume of the rectangular prism. A rectangular prism, the formula is length times width times height. So I substituted the values, 4 times 12 times 3. And really with this, it doesn't matter what order you put the numbers in. You're just going to multiply all 3 together. And I ended with 144 units. And actually, I put units because there was nothing listed. And I just forgot the 3rd power right there because it's cubed. Number 2, find the volume of the cube. The formula for volume of a cube is side times side times side, or we could do volume equals side to the third power. So you're doing 15 times 15 times 15, which is 3,375 centimeters cubed. Number 3, find the volume of this triangular prism. All right, triangular prism, the formula is for volume is the area of the base, which is the shaded part here, times the height of the actual figure. So to find the area of a triangle, it's base times height divided by 2. And then to bring it to the third dimension, we multiply it by the height of the figure. So base of the triangle is 9 times 12. We divide that by 2 and then bring it to the third dimension by multiplying by 18. With 2 and 12, I divided first and got the 2 to be a 1 and this 12 to be a 6. 9 times 6 is 54, and 54 times 18 is 972 cubic centimeters. Number 4, find the volume of the triangular prism. Again, the volume is area of the base times the height. That's what that capitalized B stands for. So what we're really doing is we're looking at the base of the triangular prism, which would be that right there. And we want 12 times 16. And then we're going to divide it by 2 and then multiply by the height. Now we want the height of the triangular prism, which is 10. This 20 right here, we do not need it because it's not showing the height of the triangular prism. So once I multiply, I cross divided by 2 to get the 16, 2, and 8. And so now I have 96 times 10, which is 960 cubic centimeters. Number 5, find the volume. The area of the base of a cube is 36 centimeters squared. What is the volume of the cube? So you're told here's the base of a cube, which is a square, and this is 36 centimeters cubed. So my hint is you got to find out what one of the sides of the square is first, and then use the formula for volume. Okay, so here's my picture. For the area, if it's 36 centimeters for a cube, we do side times side, or also, a square. And so to get 36, 6 times 6 is 36. So if the side is 6, if I'm finding the volume, it's side times side times side. So 6 times 6 times 6, which gives you 216 centimeters cubed. So that means the answer is C. Number 6, find the volume of the rectangular prism. Formula is length times width times height. 4 times 5 times 10. 4 times 5 is 20, and 20 times 10 is 200 cubic meters. Congratulations, you have completed week 23 spiral. Make sure that you're turning your corrections into your teacher so that you can get credit for them. And we're ending with a picture of PJ laying, snuggling his first stuffed animal I ever got him. He's had this since he came home at 8 weeks old. So I will see you guys again next week for week 24 spiral. Have a good week.